Hi everyone, myself Krish Raidu and very warm welcome to all. And this is day 4 Foundation AI series. And in this day, we're talking about like evolution matrix. So, what is evolution matrix and importance of evolution matrix? So, uh, so that's the important point, and you should to know about like. And have you ever wondered about like how can you know the performance of your own model, like your LLM model you design, and how you track this all this model performance and all this stuff, and how the actually engineers and data scientists know the model performance and biases and taking risk, how they actually know this is model capable for taking risk for real world scenario or not. So is it only single accuracy score is enough? So there were lots of things running behind the scene, you can say. The single accuracy score, we should to know about it, and that's the important point. You should to know about evolution matrix. So I think like we need to know evolution matrix. So I will break down this particular entire evolution matrix topic in such as three agenda. The first agenda is all about you can say what is evolution matrix and how the evolution matrix is important. And second agenda is all about you can say uh, looking toward the different types of evolution matrix that you should to know about it, like classification matrix, regression matrix, and you can say lots of example, lots of method like biases matrix and all this stuff we are looking in the second agenda. And our third agenda is all about you can say we're looking toward the real world scenario. So we tied this all these concepts, regression matrix and all this stuff in such a real world example to explain you like how this all each class evolution matrix work and play important role in such way. And uh, that's all. I will try to explain you this, all this topic in such a way you can understand much clearly and frequently. And so please like and subscribe for further more updates. And if this particular video is going to productive for you, and if you learn something there, then it's my pleasure. And so let's get started. Let's come to agenda number one. And in this agenda, we're talking about like evolution matrix. So what is the evolution matrix, and what is and why this is important? So I start with this particular concept about agenda one with a three question, like two question, like sorry, what is evolution matrix and why evolution matrix? So basically, uh, the first definition, what is evolution matrix? So evolution matrix is all about analyzing performance according to the model input change. Okay, while developing a model, and while you developing a model, so there's lots of input parameters, so inputs and variable changes, and after this we can analyze the performance of the model. So how can you analyze the performance of the model? So is it model is risky or not, strongest weakest point, all this stuff. So that's why there I think like evolution matrix is important to know the how actually the machine learning model you can say is important or not. So the performance of the machine learning model. So looking toward there, so I think like that's the important point, and you should to know evolution matrix. So according to me, that's the importance. And if I define this evolution matrix, is all about you can say analyzing performance of the model according to time changes. Okay, according to the variable changes, according to the parameter changes. So that's helpful for understanding much better. So evolution matrix. And our second question is like why. So why evolution matrix is important? Like evolution matrix is important because of that, like in my language, if I say uh, first is to analyze the strongest point of the model. And when you're going to make on model, just you should to know about what is the strongest point of my model, like what is the better prediction, analyzing performance. And second thing is weakness, and third is thing is like risk. Like this three thing is important. And because of that, when you're making on model like chat gpt, okay, chat gpt and Google Gemini, all these AI tools are basically mad before they are test lots of time. And they are mad in such way like they are tracked by lots of the company who actually mad it, like Gemini, the Google tracked all this particular evolution matrix. Because of that, when you test in real world, so it is very difficult to and analyze in real world scenario. So it's very risky in real world. So before executing this in real world, you should to analyze the evolution matrix first, and after it you can launch your model for this evolution matrix. So the and according to me, so why this evolution matrix is important for analyzing strongest and weakest and risk about this model. And after this you can also analyzing strongest point and weakness. Then after you are able to improve the performance of the model. And So that's the very beneficial point about evolution matrix. And there are lots of type of evolution matrix we discuss further, but in my definition, let us summarize this all the stuff, right? I said you like what is evolution matrix. Or evolution matrix is all about analyzing performance according to the variable change, according to input change, and after learning the model, so what is the performance of the model, and finding the weaknesses and strongest points, and improving the model. So the best way to analyze the evolution matrix. And why this particular thing is important, in this is important because of like it is very risky to execute directly to real world scenario. So it is very accidental. For example, ChatGPT suggests you to suicide. ChatGPT is basically trained in such a way like they can never suggest you a suicide or do suicide. Because of that, they are restricted because company analyze evolution metric and bad and good points of this particular model well or not, and all this stuff. And so that's the evolution matrix. That's the magic of the evolution matrix, you can say. And so that's all about the agenda one, and I will try to explain you. So let's come to agenda number two. Hey, let's come to agenda number two. And in this agenda, we are talking about like classification of the matrix. So matrix like evolution matrix of artificial intelligence basically classify in a broader category, but we take understanding of the first metric like classification metric. So classification metric is all about, you can say, analyzing the performance of the model. Like how can you analyze your performance of the model, like what the way can you analyze the performance of the model, like what the best way to analyze the performance of the model. So basically in my recall, like classification matrix have a four category like accuracy, precision, and recall, and F1 score. So these four are creating impact on such a model, understanding the model performance. Like the accuracy is all about, you can say, the total value out of true value out of total value, like how much value you can going to predict. Okay, so what are the true value that you got, and what the total value. So out of 100 outcome that you created 100 outcome, and I think like your 5 outcome you think like this one is true, so you find it accuracy. So accuracy is all about 90% accuracy, 95. You heard lots of about accuracy, like this model have a 95% of accuracy and 98% of accuracy. But there is nothing like accuracy is important, like this is the right way to understand the model performance. But there were lots of things you should to know around it. Actually model predicting the right value, but not at very right. Okay, so like some values are false negative and true positive, and some are true negative. Okay, so in such way like we can understand this square grid, and this is square grid says all about like the possible answer. So there were 4 possible answers that any model can predict, like true negative. It's all about them that model create such as a value, okay, such as giving output, but this particular output is exactly true and it's matching from actual value, and this is actual prediction or not. So if it is a actual prediction, then you can say true positive, and if it's not, then you can say this is the two categories, false positive and false negative. The false negative and false positive is about their model of predicting negative value. Is it yes or no? Is it exactly yes or no? It sounds confusing, but you can understand like true is actual true and which is not actually true is so you can false. Okay, so this true positive that actually true, and false negative that actually false. Okay, and true negative and false positive. So this is the important to you can going to understand in such like you visualizing all the concepts, and this is an important way to understand. Like in the square grid explain you like the 4 possible answers of the any particular model. Okay, so there will you can say accuracy is important, but only looking toward accuracy for understanding the model performance, I don't think like this is a right way to understand the model performance. So that's why let's come to the precision. So precision is all about, you can say, out of true positive value, like true positive plus false negative, false positive. False positive is all about, you can say, that true negative value. Okay, so true positive and true negative value, you can say total value you got, like total outcome, that total positive outcome that you got. Okay, now suppose your model is getting a predicting output. Okay, out of 10 output, like out of 10 they predicted 5 outputs, which is you consider that true. But what are actually true? So this considered a true positive. And when you're looking toward a true positive and false positive, the true positive is all about, you can say, and false positive like 5 out of 3. 3 is your actually true value, and 5 is all about, you can say, like outcome, true outcome that you considered. But 3 is only 4, so you can 3 by 5. Okay, So that's the particular precision work, and precision important, and that's filter the one of the, you can say, model performance in such way like a true positive value. And here is like a to recall is second, and which is basically all this are sound same, and you it's sound like confusing too much to understand. But if you understand that, you should to know about like analyzing performance in such way like how much actually recall value. So recall is all about true positive and true positive plus false negative. Okay, so false negative you can say that actually true. Okay, so false negative is like actually true, and true positive value like false negative. False negative you can say something in a model can predict, but this is not at false. Okay, model say this is not. Model say, if I ask the model to is it right answer or no, so model say no, then I think like it sound confusing, but again it sound confusing, but it really understand to easy to understand, like you consider true positive plus false negative. So this is a recall score, and you should to know about recall score in such way like you can understand much clearly about recall. So recall is all about, you can saying about filter out the true positive value out of their true positive plus false negative value. Okay, so that's all about. And F1 score is the harmonic mean of this all this accuracy and recall. So recall and accuracy, so recall and precision, I think like recall and precision. And if you need to find out F1 score, like F1 score is 2 into P into R and P plus R. So this is the formula you apply to just find out. And I'm not saying that you are going to just find out this formula, but you should to know about this little bit about this matrices. And when you're looking toward the example, you can understand much clearly without just when you're looking toward on example, like when you're training a model, you can analyze much better. So you can just remember it, and in such way like you can figure it out. But when you actually analyzing the performance, that when you're looking toward answers and when you're looking to output, you can understand much better. So just you should know about like I will give you an example like when this sound confusing, but accuracy, precision, recall and F1 score is important while you're looking toward it. So that's fine. And let's come to our second classification. Hey, let's come to their bias metric. So this is a bias metric, and in this bias metric, we're looking toward their what kind of biases that data algorithm and AI, such as AI model, looking toward shifting toward the biases. So let me understand first what exactly bias is, and then after moving forward, like how can we solve what kind of the region, that what causes of the biases in this model, like LLM model. So let's start. And first we're going to understand biases. So what is biases? So in fact, bias, when we're talking about biases is all about shifting anything, like dominating one kinds of information, you can say. For example, when you're giving a chat GPT to prompt to write make an image of doctor. So image, we know that doctor have a different background. So as we know, like a dentist and all this type, dentist and surgeon and all this stuff. But when we see the chat GPT to make a like generate an image of a doctor, they did choose the dentist. Then this particular image they generated, why the particular model choose this particular thing, and like consciousness of this particular model shifting toward their only for dentist, you can say a dentist and doctor. Okay, when we say the generate an image of doctor, then particular model says that generate an image of dentist. Why this? So that's the biases. So biases is all about to making one dominating and shifting of all the data in their one direction of any specific, giving you suggestion for any specific image like dentist. Okay, so that's the biases in the particular model, and that's called biases, like shifting of model in one direction, like shifting of model into generating something in one direction. So there were two reasons, right? I think like the biases is like the first one is data, and second one is algorithm. The first one, data says that varieties of data, like all this data have on a huge data sets. Okay, so huge data sets are basically divided in the such as all this shifting of all data in one direction, like you given a lots of image about dentist and you give a few image about surgeon. So I think like out of 10 you 9 image about dentist and 5 image about, you can say, surgeon. One image about surgeon. So you're when you say the model to generate a image, then the model always generate an image for dentist. Because of that, there are lots of data, and the model trained a huge amounts of data of the dentist instead of your surgeon. So that's the one of the best reason, you can say, biases shift according to data. And second thing is algorithm. So how do you algorithm design? So designing algorithm in a such way, like when you're designing algorithm, like algorithm, when you design algorithm, so the process you are making, giving the model to make decision, then you can create biases in such as fault in shifting toward the one specific. Like for example, you give it a 100 image and you said the model to always suggest this particular thing, like image of the dentist, and that the process you design to suggest only for one data points. So that's the algorithm. That fault of algorithm and data fault and data variance fault and variety of data in distributed variance of data and algorithm is two main causes of the biases. And for this fixing biases, you need to fix about data variant and you can say algorithm, and you can take a human in loop, like a human which regular monitor this all the particular training and looking toward the biases and shift and fixing this all this stuff. And that's the way that you can look toward their biases. How can you improve these biases, and how can you just remove these biases from the any model and any stuff. So that's all about bias algorithm. Let's move toward other. Hey, let's come to the other types of metrics, like interpretive metrics. So interpretive metrics refer to, like it's all about, you can say, to your model is trained, and how you want to know about like which features dominate into making a decision, and which feature contribute what kind of the uh, impact on this particular making decision. Like now suppose you have lots of output, like okay, now suppose you are training a model, okay, and there were three features of the your training model, like the first one is location. And now again I will take a best example for understanding much better. Like you're predicting house price, okay, and you make a model to predict a house price, what is the house price of the particular house, and PG, and you can say anything else. And there were two kinds of the features that you give, like uh, you can say area, and second one is location, and third one is you can say uh, process, like area square, and like how much the area occupied in such area, like and type frontal loop. Okay, so the first one is like area, how much the area did occupy, and second one is location, and third one you can say, and how many rooms are there. So there were three features that you give. And when you're predicting house price, then I think like the which features dominate much more and more in contributing the output. The first example, location. So location is how much the location play an important role to contributing an example. And for example, like location and you can say location and house, like how much the where is the particular location, and second is the how much the area is and how many rooms are there, okay, in this particular house. So there's are three features, and you want to know about which features, like how much location matter to predicting a price. Like you got on a 15,000 for house price in this particular location, okay. Then you want to know which particular feature give a highest contribution in their predicting house price. Then the one most example, like the you can say the best process to know about is Shapley value. So Shapley value help us to identify the contribution of the feature, like out of this three feature, which feature contribute how much in this particular predicting a price. So the process to finding a value is like the just break down this all the sequence in the three process. Now suppose you have a three feature, then we'll arrange this particular three feature in such a six sequence, like a dominating a out of there, adding the a, what kind of the impact that you got, okay. After adding and before adding, then three sequence, okay. After the sequence you can add this all and find out the average and divide this particular average, and you get the contribution out of this particular three. And that's the important one, and you should to know according to it. The Shapley value help us to identify the which one is the best important, and which one feature is contributing much important like role in this particular output. So that's the important point of the particular interpretive matrix, and important, this is interpretive matrix is very important while looking toward it. And let's come to other matrix. Hey, let's come to the other matrix. Like the first one is more, this matrix is known as a cross validation matrix. And in this cross validation matrix, let's be looking toward their what is the, how can we know that how model react, what kind of model reaction, like knowing the model outcome when they're looking toward the new unseen data. So that's a very important to know. Like when you're training a model, like in some kinds of the information, some kind of data set, then if you remove some data set, then how the model react and what the performance of the model. So for example, and you have a temperature data, like you have a model like we're predicting the weather and weather price and all this stuff, but you want to know that how much model react and what the model reaction, what is the model reaction, and when they look this data, okay, and unseen data. So it's all about a cross validation matrix. For example, cross validation matrix considered all model data, like data set as a k, for example k minus 1, and we removing one data set, like distributing the whole data set in 5 points. Now suppose like you open a data and you consider this data as a 10, okay, then it removing one data set and giving a model to just train itself and predict performance, then you can know the model, how much the model going to predict in such looking to unseen data. So that's the basic point you can say about cross validation matrix. And cross validation matrix is all about, you can say, to analyzing the performance of the model while looking toward their unseen data. So let's come to there. This is enough for this particular metric, and the classification metric is enough, and you should to understand much better because of that this important concept. And you need to just know about this particular metrics. While you making that, you need to know, you not need to do actual calculation, but you should to know about theoretical knowledge. Because of that, when you're looking toward any model, you can analyze much better, like which kind of metrics and like evolution metrics, how the performance of the model, and in such all these domains like classification, regression, and all this stuff. So that's all about it. And let's move toward that third agenda, real world example. Hey, let's come to the agenda number 3. And in agenda number 3, we are talking about real world example to understanding the how this particular matrix are work in such a real world example. I'm not comfortable here because of that. My whiteboard is such as switching and lightning, right? Right now too much. So that's why I will explain you clearly in my voice. Like I will transfer your knowledge and whether by voice and without any diagram. So that's okay. Let's come to the point, like uh, how the particular matrix are important in real world scenario. Like this matrix is important, like when you're testing any model in real world scenario, you look at lots of advantage, disadvantage, like lots of failure and risk, and that's the important. Okay, okay, so let's take one best example to understanding how this matrix are important in real world example. So okay, so the first example, you can say image generation model. So when you're generating your image, so you need to find out accuracy and precision and F1 score recall, all this stuff to know the how well this particular model generating a image, predicting generating an image. Okay, so that's the how classification metric is work. Second is your when you're generating an image, that you should to know also know about like interpretive metric, because of that when you making your own model, like which features of generating an image is more used. Okay, which feature dominate when you're generating an image, so more used. Okay, second thing is your regression matrix. Regression matrix is all about MSE, MAE, and R squared, mean squared error, the how much error that it create when you're looking toward their making the predicting an image. So how much the error, so the MSE, mean squared error, mean average error, and R squared, like how well this particular data is used to predicting such an image, how much part data of the data is used to predict such image. So that's the particular thing. Okay, and second one is a cross validation matrix. So cross validation matrix is all about, as you know, like uh, all the data set looking toward their new unseen data and how the model is looking toward and generating image. So that's okay, and looking toward the data, and that's well you making an image like doctor. For the cross validation matrix work here in such way, like you can say it predict the image, okay, by looking toward the different angles of their value training a different data sets. Okay, and they look toward the unseen data and they predict it. Okay, so that's how the real world example work, and I think like that's the best example to understand it. And so that's hope, and I will try to explain you all this particular concept in such a way you can understand much clearly. And thanks for watching, and see you soon.